Alright, this is University of California at Santa Cruz, People's Physics textbook number 16, part C. Same initial conditions, obviously. Initial position is 20 meters above the ground, the origin. Initial velocity is 12 meters per second with free fall acceleration. We found the final velocity of negative 23 meters per second. We found the elapsed time to hit the ground of 3.6. However, now we want the maximum altitude, that is the final position at the apex of the person's flight. So, the final velocity is 0 at the apex. So we're going to use that fact with the second fancy equation, that is final velocity squared minus initial velocity squared equals 2 multiplied by the acceleration multiplied by the displacement, except now we're going to isolate the displacement, expand it into final position minus initial position, and divide both sides by 2a. That pushes this term into the denominator, and we're going to add the initial position to both sides. So let's substitute in initial velocity of 12 meters per second, negative 9.8 as free fall acceleration, and like I said, 20 meters as the initial position. We grind through the math and we find that the person goes 7.34 meters above the initial release point. However, because we're starting at 20 meters above the ground, the question asks for the maximum altitude. So 7 1/3 meters plus 20 gets us 27 meters above the ground at the apex. That's University of California at Santa Cruz, People's Physics textbook, number 16, part C.